Year 11 mock exam, question 6. This question is a real, what we call novel information question. You're given information that you are not aware of in the past. So that's, again, something that should not scare you. You should look at this and you should think, yes, recognize this is novel information. So we've given us two chemical equations in the extraction of titanium. You're not required to understand or know from the specification anything about the extraction of titanium. Suggest one hazard from stage 1. Well, let's look at stage 1, and we can see stage 1 forms titanium chloride and it forms 2 carbon monoxide. It also uses chlorine gas. There are a couple of different things you can have here, but the most obvious one is carbon monoxide, or CO, is, now be very careful what word you use here. Harmful is not enough. We need to actually say that it is actually going to cause death or damage. Harmful could just be a small itch or a rash. We need to say, and I'm going to use the word toxic. Could also use the word poisonous. I prefer to use the word toxic in this. You can actually go into details of what it does, that it bonds with hemoglobin, but that's really unnecessary in this response. You can just say toxic. Knowing that carbon monoxide is toxic is covered in the atmospheric chemistry topic in topic 9. So this is actually a paper 2 question. Water must be kept away from this reaction in stage 2. Give one reason why it could be hazardous if water comes into contact with sodium. Now, there are a few answers for this, and the answer that wasn't acceptable that a lot of people put down is sodium reacts vigorously with water. The word vigorously was thought not to be very descriptive. So vigorously could just be quick, but it doesn't really explain. What's the real danger here is that it's very hot. It's producing a lot of heat energy. So in the reaction, you can say that a lot of heat's produced and it forms a very either explosive or violent reaction. In the reaction, lots of heat is produced, okay, which then you can write as exothermic. That gets you the mark. Saying it's exothermic, saying just lots of heat gets produced actually doesn't get you the mark, but saying it's exothermic does. You could also say it's explosive, or you could say or causes a fire or ignition. So what's actually going on? Well, this is a basic reaction of sodium with water reaction in group 1 metals, that sodium really produces a high amount of energy, and normally when you're doing it in the lab, though, it doesn't actually ignite, it just melts into a ball, and at the end sometimes the hydrogen gas can explode, and that's why we say it's explosive. So the key word here is that we could not use the word vigorously. Vigorously was not considered to be descriptive enough in this term. Suggest why the reaction in stage 2 is carried out in an atmosphere of argon and not air. So this relates to group 8, noble gas content. So the sodium will react with, you can either say oxygen or water vapor in the air. Could not say just the air. That's not enough detail. You've got to say either with oxygen or with water vapor in the air. But argon is inert. There's your keyword, or unreactive fiber, inert. So will not react. Can't spell. There we go. So will not react. So key point there, air. Lots of people writing down sodium will react with the air. It's not reacting with air because air isn't a thing. Air is a mixture. And so oxygen or water vapor is what you need to say. Question 6.4, sodium chloride is a liquid at room temperature. So sodium chloride is a liquid at room temperature. Explain why you would not expect titanium chloride to be a liquid at room temperature. Explain why you would not expect. Okay, so looking at this, titanium chloride, you would expect titanium chloride to be an ionic compound. Why? Because it's got a metal and a non-metal. So you would expect TiCl4 to be an ionic compound. That's straight away 1 mark. You would expect it to be an ionic compound. Now, what do we expect ionic compounds to do? Well, we expect ionic compounds to have high melting points. So we can say ionic compounds have high melting points, and then we can give a reason why. Okay, or you can put in brackets are solid at room temperature. But now we need to give a reason why. So because, ever important word in science, because the forces of I'm going to actually use the word electrostatic forces. The electrostatic forces of attraction are strong. And that's the really important. The forces of attraction or electrostatic forces of attraction between the ions are strong. You can even actually improve that, I'd say, by putting between the ions. Okay. Going to add that. Between the ions are strong. The between the ions actually is very important. You need the between the ions to get the mark there. So sodium ions are oxidized to sodium ions. So sodium atoms are oxidized to sodium ions in a reaction. What is an oxidization reaction? Straight away we write oil rig. Oxidation is loss, reduction is gain. So really, really useful acronym. So we know that sodium ions are oxidized. So we need to say sodium, and we have to be specific to say sodium. Sodium atoms, they're being oxidized. So oxidization, okay, is loss. So sodium atoms are losing an electron. You could actually just say losing electrons, it's fine, but we know that Na plus goes to, Na goes to Na plus by losing 1 electron. Complete the half equation. Well, that's actually just what I've said, that Na goes to Na plus an electron. You have to write E minus. If you just write down E, that's not correct. You have to write down an equation. You can't write down in words. It has to be Na plus and E minus. Question 6.7, the big maths question. Now, this is a very important question for how we lay it out. So we're going to lay it out very carefully. Explain why titanium chloride is the limiting reactant. So when we're looking for a limiting reactant, we're looking for the one that does not have enough moles to react. So straight away looking at this, we know that 1 mole, because there's a 1 here, remember, it's invisible 1 mole of titanium chloride plus 4 moles of sodium goes to 1 mole of titanium and 4 moles of sodium chloride. So we need 1 mole of titanium chloride for every 4 moles of sodium. We're giving 40 kilograms. Now, straight away, we have got a warning flag here. This is in kilograms. This is not physics. This is chemistry. We do not work in kilograms in chemistry. We work in grams. Straight away, you could lose 2 marks for not doing the conversions. So we're going to lay this out in a very, very specific way. We're going to write down here TiCl4 plus 4Na. We don't need to worry about the rest because we're looking at reactants. We're not looking at products. We need to start with the MR. And we look across here and we need to calculate the MR. So straight away we've got 48 plus 4 times 35.5. And then we've got 4 times 23. It's important to put these workings down. It's important to make sure you are writing the workings. So we're going to have 4 times 35.5. That gives us 142. Add 48 gives us 190. And 4 times 23 is going to give us 92. So now we need to work out the number of moles. And moles is going to be equal to, we can write this anywhere we want. I'm going to write it up here. So moles equals mass over MR. So moles is going to equal mass, and we're told the mass here, titanium chloride, is 40,000 grams. You can put the grams in if you want. Divided by the MR, 190 equals. So let's do that. 40,000 divided by 190 equals 210.526. Could give myself a little bit more space here on this side. So now I'm going to have sodium. Sodium's got 20,000 grams divided by 92, which is going to equal 217.391 grams, moles. So for all of the titanium to be reacted, it would need to have 4 times that number of moles of sodium. So far, actually, we've got 3 of the 4 marks. We've got 1 mark for working out this. We've got 1 mark for working out this and 1 mark for working out this. So if you have not calculated the masses in grams, you've already lost 2 marks here. So now we actually need to put an explanation. So the way I'm going to explain it is this. I'm going to say for 210.5, I'm just going to round there, moles of titanium chloride to react completely, it would need how much? It would need 4 times that because it's a 4-to-1 ratio. So it would need 4 times 210. It would need, so 4 times 210.5. It would need 842 moles of sodium. So sodium is the limiting reactant. And that's our 4th mark, the explanation mark. Okay, there are other ways to explain it. You could just say that the titanium is not in excess because there are less moles than required to fully react. But this way explains it very clearly and uses the moles that you've calculated in your explanation. Much easier question. Lots of people got this, even if they didn't get the previous question. Actually, just going back to the previous question, if you hadn't used grams, then the only marks you could have got were the first marking point for 190 and the last marking point. So lots of people were getting 2 out of 4, but they were out by a factor of 1,000 on the number of moles produced because they did not convert to grams. So yield is just mass divided by theoretical mass. So let's just write that down. Yield is mass over theoretical mass. And so we've got our mass here. The maximum theoretical mass of the batch was 13.5 and the yield is 97. So we need to rearrange that. So we have, if I write it out fully, we have 92.3%. I substitute equals mass divided by theoretical mass, 13.5. Now I can rearrange and do 13.5 times by 92.3. And we get 13.5 times 92.3. We get 1,246.05 kilograms. Okay, but we actually don't get that because we haven't divided by 100. Okay, so that should be mass times 100. So we need to actually also divide this by 100. So that's going to be 12.46. You could also get the mark there for saying 12.5, but it doesn't say that you should be rounding it. One of those rare cases where it doesn't actually state whether you should round something or not. So 12.4 or 12.46, sorry, 12.5 or 12.46 or 12.461 was allowed. Note that you can't have 12.4. Why can't you have 12.4? Because 12.4 is not 12.46 rounded. You've just forgotten to put the 6. So anybody that wrote 12.4 would only get 1 mark for showing they're working. So we know that times 100, that should be the correct working there. Okay,